Okay, so an exponential equation. So there's two things that an exponential equation will have. It will have an equal sign. That's what makes it an equation. And it will have variables that are exponents. So we're looking for an equal sign, and we're looking for variables that are up in the exponent position. So they'll always take this form, a times b to the x, where a will be a number that is not 0. B will be positive and not 1. And then x is going to be our exponent. And it will be a variable. So we will have a variable up in the exponent position that we're going to have to solve for.
Wait, what does that say? Number of something 0?
The number, it does not equal 0. The number does not equal 0. So then the last thing is that, oops. If exponential equations, and this is how we're going to solve them, if they have the same base, and the base is the number that's like down here. This is the base. This is the exponent. So if they have the same base, we can also assume that their exponents are equal, and that's how we're going to solve for the exponent. B of b to the x power is equal to b to the y power. Because the bases are the same, we can assume that their exponents are the same. So we can say that x equals y. So that's kind of the key thing with solving exponentials, is we always want the bases to be the same. This one, 3 to the x equals 3 to the 5th. If we were solving for x, because the bases are the same, we can then say that their exponents are equal and that x equals 5. So the key here is to manipulate the bases so that we can then set the exponents equal to one another and solve for x. So you have to be good at your powers, okay, so that we can change bases to have different bases with exponents. For example, 2 to the x equals 8 to the 3rd. We need to solve for x. The way we are going to do this is by changing 8 to have a base of 2. How could we rewrite 8 with a base of 2? 2 to the 3rd. 8 is the same as 2 to the 3rd, right? 2 times 2 times 2 is 8. So instead of saying 8 to the 3rd, we're going to say 2 to the 3rd to the 3rd. So now, what do we do with those exponents? Multiply. So we get 2 to the x is equal to 2 to the 9th. Now our bases are the same. We can set our exponents equal to each other, and we know that then x equals 9. We have 9 to the 2x minus 1 equals 3 to the 6x. We need to get the same base. So we can change 9 to have a base of 3, right? 9 is the same as what? 3 squared. So we're going to do 3 to the 2nd. 2 to the 2x minus 1 is equal to 3 to the 6x. Now watch here, because you need to be careful. We need to distribute that 2 to both terms that are outside. So when we set our new base, we'll have 3 to the 4x minus 2. Don't forget that step. Equals 3 to the 6x. Okay, from here, now our bases are the same. We can set our exponents equal to one another and solve. So now we'll just write our equation is 4x minus 2 equals 6x. And then we'll just solve using algebra. So subtract 4x from both sides. We get negative 2 equals 2x. Divide by 2. So x is equal to negative 1. 4. Okay, we can leave this one then as 4 to the n minus 1. But we can, 4n minus 1. Thank you. How can we rewrite 64? 4 to the third. So we're going to say 4 to the 4n minus 1 is equal to 4 to the third. Now that our bases are the same, we can set just our exponents equal to each other and solve for n. So we get 4n equals 4. Divide by 4, divide by 4. N is equal to 1. To write an exponential function, you are going to use this formula. Y equals A times B to the x power. A is the starting value of whatever you have. So sometimes like it's bacteria and it's like bacterial growing at an exponential rate. So A is how much you start with. So starting value. B is the rate of growth or decay. So how fast it's either growing or decaying. If your number is bigger than 1, it's growth. If it's a fraction or a decimal that's less than 1, it's going to be decay. It's going to be getting smaller. Growth or decay. Okay, and then x, this exponent in an exponential represents time. So how much something is growing or decaying over time at an exponential rate. All right, so if we have y, we know that that's how many they end up with after 4 hours. They started with 7,500. We don't know the rate that it's growing at, and it's to the 4th power. We need to solve for b so that then we can write the equation that's modeling what's happening here. So to solve for b, first divide both sides by 7,500. Which gives us 3.067. Okay. How am I going to get b by itself? Fourth root it, right? Fourth root, because that's the inverse of taking something to the 4th power. And the 4th root of that number is 1.323. Times b, which is 1.323 to the x power. We can plug in any time now and figure out how many bacteria there will be after that amount of time. How much did it ask us to find? 12 hours. X. 7,500, 1.323 to the 12th power. Be super careful here. First step here. What's the first thing I should do? Multiply? Order of operations says I should do what? The square. Exponent first. So you must do this first. Okay? Exponent first. So first you take 1.323 to the 12th, and then you multiply by 7,500, which gives us 215,665 bacteria after 12 hours. Okay? This models exponential growth. Typically with money, when your money is compounded at a certain rate over a certain amount of time, and they compound not only the principal balance, but everything you've made. So it's a fast growing rate. Here's what we will need. Okay, P is your principal amount. It's what you initially deposit, or how much you start with. So A is going to be the end amount. That's what you end with. P is your principal. 1 is just 1. R is your rate. You must always write R as a decimal. You will typically be given it as a percent. So if they say that the rate is 2.4%, you can't put in 2.4. You must change it to a decimal. So change a percent to a decimal. We get rid of the percent sign, move our decimal 2 places to the left, and add a placeholder 0. So we would put in 0.024 for our R and not 2.4. So you always have to change the percent to a decimal for it to work in the formula. Okay, N will be the number of times that the money is compounded yearly. Bless you. So if they say that it's compounded every day, then N would be 365. If it's compounded quarterly, that would be 4 times a year. So N would be 4. If it's compounded yearly, N would be 1, once a year. Okay? And then T is going to be time. So basically, you're going to be given all but one of these, and you'll have to solve for one. But using this to start and then working backwards is how you're going to have to solve the problems. All right, let's do number 1. So it says an investment account pays 4.2% annual interest compounded monthly. If $2,500 is invested initially, what will be the balance after 15 years? So let's identify what we have. We have the rate, right? That's our R. How should we put this into our formula? Decimal. 0.042. We want to make sure that we put that in correctly. We also know that it's being compounded monthly. What does that mean? What is N going to be? 12 times a year. 2,500 invested initially. What's that going to be? Principal. Yep, that's our initial. And then it says, what will the balance be after 15 years? What's 15 years? Time. So now we're going to plug all this in to our formula. P times 1 plus R over N to the NT. And then we just plug in what we know. A equals the principal, 2,500, times 1 plus R, 0.042, over 12, to the 12N times 15T. Okay, your order of operations is super important here. Okay, first, we should do this division, and then we'll add it to 1. So 0.042 divided by 12 is 0.0035. So we'll have 2,500, 1.0035, and then 12 times 15 is 180. Okay, what's my next step? This is where things fall apart. Exponent. You must do this first. Do not do 25 times 1.0035. You won't get it right. So if we take 1.0035 to the 180, we get 1.875. Multiply that by 2,500, meaning after 15 years, we will have 4,688.87 cents. This is typically money. So if you have money, always go out 2 decimal places, right? Like cents, 87 cents. Compounded monthly. How much would she need to invest for the value to reach $190 in 7 years? So what do we have? We've got an interest, right? That's our rate, which is what? 0.04. Change it from a percent to a decimal. Compounded monthly. Yep, N equals 12. Compounded 12 times a year. How much would she need to invest for the value to reach 190? That's going to be our A value because we want that to be the ending value in 7 years, and that is our time. So let's plug all that in. So we know that 190, that's our final amount, equals P times 1 plus 0.04 over 12 to the 12 times 7. Now we're solving for P, right? So we're going to do all the algebra and then get P by itself, and that'll tell us how much she needs to invest to start. So 190 equals P. 0.04 divided by 12 is 0.0033. Add that to 1. Bless you. And 12 times 7 is 84. What should I do now? Exponent. Okay, so then I get 190 equals P times 1.3188. Bless you. Last step, to get P by itself, what should I do on both sides? Divide by 1.3188. So our principal, the amount that she would need to invest in an account growing at that rate, would be $144. Oops. And 7 cents. So always going out 2 decimal places when we're talking about money. $78,000 in an account and leaves it for 7 years. If interest is compounded daily and he ends up with $91,000, what is the interest rate? So we're solving for R. Here's what we have. We have the principal. That's what he started with. We have what he ends with. We also have time. And they said it's compounded every day. So what is my N? 365. All right. So we plug this all in. 91,000. That's our end up. Equals 78,000. Times 1 plus R, which we don't know, over 365 to the 365 times 7. Okay, watch this one because this one's harder. Because look, the R is like stuck in there in a place that's hard to get to. So we're going to have to do this one a little bit different. Okay, first, if I multiply this out, 365 times 7, I get 2555. Okay, so now, since I'm trying to solve for R, I can't do my exponent first because I have a variable that I haven't solved for. So first, I'm going to divide by that 7,800 because I'm trying to get in to get to that R. So divide each side by 78,000, which gives me 1.166 forever. And then I get 1 plus R over 365 to the 2555. Okay, what's my next step here? I need to get into those parentheses, which means I need to get rid of that exponent. What kind of a root am I going to take?
2,000.
Yes, I'm going to take the 2555th root of both sides. So you can do this on your calculator. It's in the math menu. So like if you were doing this on your calculator, you'd go to math. And then I can't remember which one it is, but it looks like this. Yeah, it's like the xth root. And you would put in 2555 for your xth. Because that's going to get rid of that exponent and allow us to get into the parentheses. All right, so round way out on this. Because it gives us 100,006,0335. So just use what your calculator gives you. Because otherwise you're going to end up with 0, which doesn't work. So keep going way out for this part. Now to get R by itself, subtract 1 from both sides. So now we just get 0.000060335 equals R over 365. What's my last step? Multiply by 365. Which gives us a rate of 0.022, etc. but I'm going to give that as a percent. So what do I need to do to change that decimal to a percent? I need to move it 2 places to the right and add a percent sign. So my rate is 2.2%.